Four congruent isosceles triangles each have one angle of 90 degrees, and they're inscribed in a circle of radius 6 in the pattern shown here. So we can go ahead and draw the rest of those in. Let's put this line here and this line here. I'm not going to dot them, I guess, because I'm a bad person. But we have three other triangles here forming a square. So for our answer, the area of the circle minus the area of the square within it is going to be the area not covered by the triangles. Let's see what we can do. So the circle has a radius of 6. So this is 6, this is 6, this is 6, and this is 6. What we really need to figure out is the length of one of the sides of the square. One thing that's really handy to remember about squares is when you have the diagonal, they form two 45, 45, 90 triangles. And the ratios of the sides opposite those angles, so if you have 45, 45, 90 triangles, the sides opposite those respective angles are whatever measure, and whatever measure times the square root of 2. So if you have the side length of a square, the diagonal length is whatever the side is times the square root of 2. So in this case, our x's are 6, 6, 6, and the side of the triangle, which is the diagonal of a hypothetical square, that is 6 times the square root of 2. So the side of one of the squares is 6 times the square root of 2. The area of the square, remember, area of a square is equal to the side value squared. And therefore, we are doing 6 times the square root of 2 quantity squared, which equals 6 squared times square root of 2 squared, 36 times 2, or 72. So the area of the square is 72. And then we have to subtract the area of the circle. Area of a circle is pi times the radius squared. We have the radius is 6, so it's 36 pi. That does not appear in any of the answer choices. However, both 36 pi and 72 are both divisible by 36. Factoring out of 36 gives us 36 times the quantity pi minus 2, which is answer choice A.